Alright, so in this video we're going to be talking about graphs again and graphs of lines and other types of functions and the idea of intercepts of these graphs. And so if you're a football fan, you've heard this word before, like so-and-so intercepts the ball, and that means he catches it. So we're talking about where a line, quote-unquote, catches a point, where the line crosses at the axis or whatever function we're talking about. So we're talking about x and y intercepts here because we have two axes, x and y. So an x-intercept is where a graph crosses the x-axis, of course, and it's going to be in the form of a number, comma, 0, because the y value is always 0 when you're looking for an x-intercept. Think about what the graph looks like. Your x-intercept is the horizontal one. So we haven't moved up or down any, so we're sitting on this axis somewhere, so the y value has not changed. It's 0. Same thing with the y-intercept. Y-intercept is where it crosses the y-axis, obviously. And it's in the form of 0, comma, a number, because now the x value is always 0, because if we're sitting on the y-axis, the vertical axis, we haven't moved left or right, so the x values are always 0. So keep that in mind. If I want to find the x-intercept, I'm going to plug in 0 for y. If I want to find the y-intercept, I'm going to plug 0 in for x. It's like opposite. So if you want to write yourself a note, think opposite, and we'll go through some examples in a minute to show you what I'm talking about. So, now that you got that idea, here's a visual again. So, y-intercepts fall on the blue vertical line, and I've drawn you an arrow, so anywhere on that vertical axis they can fall. They don't have to be whole numbers. We could have a y-intercept of 1.25, or some kind of fraction or decimal. So don't think that if you get a nasty number, you're wrong. You're not. And then the x-intercepts fall on the red horizontal line. So, you got the basics down. Let's talk about examples. So, in this graph, graphs are going to be the easiest way to find these things. All you really have to do is know what axis is what. So hopefully you're looking at this and knowing that this is the x-axis, this is the y-axis. So if I want x-intercepts, I can see that right here the x-axis has a point that's crossing on the line. Now if I'm looking at y-intercepts, I can see that the line falls here on the y-axis. So those are two of my intercepts, the only two intercepts I have. So if I want my x-intercept, I know I'm talking about this point. And you just got to be sure that you're putting 0 in the right spot. So the x value here is 4, the y value is 0, because remember you haven't moved up or down for y. Now for the y-intercept, it's the opposite. Remember, it's 0 goes in the x spot, and you've gone down to -3. So that would be your y-intercept. So graphing, all you really have to do is recognize where they're crossing and make sure that you're putting the 0 in the right spot. Alright, another example. This is a function, again, that you probably aren't going to see too much of until sophomore year, but it's called a quadratic function. It's a parabola. So we can still talk intercepts for any function. It could look crazy. We could still talk about intercepts. It's just wherever it's crossing the x-axis or the y-axis. So they've already labeled the x for you here. The y is this one. So again, if I want x and y intercepts, I'm looking for where they're crossing the axes. So there's one, there's another. So there's actually two x-intercepts here. And there is only one y-intercept right here. So let's start with our y-intercept because there's only one. So remember, for y-intercepts, the x value is 0. And my y value is wherever I'm crossing, -5. So y equals -5 is where I'm crossing. Now for my x-intercepts, we know there's two of them. So let's look at the left one first. So remember, the y values are both going to be 0. So I can go ahead and put those in. Now on the left here, let's just estimate. Let's not make it complicated. Let's call that -1.5. Maybe that's not exact, but it's close enough. And on the right over here, let's not make it complicated. Let's call that maybe 3.5. It's in between 3 and 4. So those would be our two x-intercepts. So you can have as many intercepts as you want. You're just looking for where it crosses the x or the y-axis. You've got to keep that in mind. Alright, another example. This one's a little tricky, but don't let it confuse you. X-intercept, well, we see where it's crossing the x-axis. There's the x-axis, so I'm crossing here. So there's a point there, and it's 1, 0. But where does it cross the y-axis? So let's just talk about real quick where we're looking. Y-axis is right here. Am I ever going to cross there if this line is going vertical? No. So, on this certain case, we're just going to say there is none, or you can say NA or none, however you want to write it. Don't put 0 because 0 is a number, so I don't want you to confuse 0, 0 as an intercept. That's not an intercept. So just put NA or none. Alright, so in this special case, and there's another special case we'll talk about later, there is only one type of intercept. It's the x-intercept. Alright? All right, one more graph, just another kind of graph to look at. This is not a function. All right, it fails the vertical line test, which we'll talk about later. But it is a graph we can look at nonetheless for intercepts, and they've actually pretty much spelled them out for you right here. So I'm crossing here, and I'm crossing here. Those are x-axis intercepts. So those are my two x-intercepts, and they already wrote them out for us, -6, 0, -2, 0. But again, my y-axis is right here, and my circle is nowhere near touching that axis, so I don't have any y-intercepts, so we're just going to put NA or none. Alright, so let's talk about if I don't give you a picture. Now, of course, we've talked about how you graph lines in this form, so you could go graph this, sketch it out, and see what your intercepts are. But let's think about what we already know about this form of an equation. We've got y equals mx plus b here, slope-intercept form. Well, I know m was my slope, but what was my b? Well, hopefully you're remembering b is my y-intercept. So in this form, if we're in slope-intercept form, you already know what your y-intercept is. My y-intercept here is going to be the point 0, 3. I'm going to go up 3 on the y-axis. Now, it's not explicitly stated what the x-intercept is, but remember, if I want to find the x-intercept, so to find x-intercept, I'm going to plug in 0 for the opposite letter for y. Alright, so let's do that. We're going to put 0 in for y. And now we just got to go solve for x, solve an equation like we've talked about. So I need to undo the add 3. So -3 equals 2x. And then I need to get rid of the 2 and make those cancel. So x now is by itself, and x equals -3 halves. So my x-intercept here, and again, just because it's a fraction doesn't mean you're wrong, the x-intercept is -3 halves 0. Remember, we plugged in 0 for y, so there it is. So those would be your two intercepts. One of them was explicitly given right here. This one you had to go find a little bit. Alright, next one. And if I'm going too fast, pause it and rewind it. We've got to get somehow, either in slope-intercept form, or just go ahead and plug 0 in for two different things. So I'm going to do it the way I think it'll be faster eventually for you. You could go sit here and get it into y equals mx plus b and rearrange it. But unless we're trying to graph this, there's really no point to do that, because this form is easy to graph in, but it didn't tell us to graph it. So, since all I'm interested in is what the x-intercept is and what the y-intercept is, I'm going to go just do it algebraically, because we already talked about what you plug in to find. So we know that if we're looking at an x-intercept, the y value is 0. And if we're looking at a y-intercept, the x value is 0. So I just got to go plug 0 in twice, and we like 0 because 0 does some cool things in math. So let's go try it. So for our x-intercept, it says plug in 0 for y. So I'm going to have 2x plus 4 times 0 equals 12. Well, what's 4 times 0? Well, hopefully you know that's 0. It's going to knock itself out. So what we're really looking at is 2x equals 12. That's why we like 0. Divide by 2. So x equals 6. So we plugged in 0 for y. Well, now I know what my x value is. It's 6. So my x-intercept is 6, 0. I want to go do the same thing for y now. So if I want my y-intercept, I need to go plug in 0 for x this time. So I want 2 times 0 plus 4y equals 12. Well, 2 times anything, or 0 times anything, sorry, is 0 again. So that knocks itself out. So we're left with 4y equals 12. Well, now we just got to get y by itself. So y equals 3. Well, there it is. We plugged in 0. We got 3. So there are my two intercepts. And it wasn't much work. It was just plugging in zeros. And we like zeros because they knock things out. 0 times anything is 0. Pretty cool property to know about in math. So let's try some on your own. So again, if you're not comfortable on your own yet and these don't make sense, go back and rewind the video. But at this point, if you're ready to try, pause the video, write these down. And I want you to find both intercepts. I want the x-intercept and the y-intercept. And you should only have one apiece on these. Alright, we're not going to look at any of the crazy functions I showed you in the examples. We should have one x and one y. So pause the video. When you're ready, come back and join me, and we'll check your answers. Alright, here's your answers. Number 1, y equals -2x plus 7. This is already in slope-intercept form, so remember, I've circled what your y-intercept is. It's the b in this formula. So we already knew that our y-intercept was 0, 7, so I went ahead and wrote that down. But now to find the x-intercept, remember y is 0 on an x-intercept. So we plug in 0 for y, which I've done in blue down here. And I've just solved it. And once you get it solved, you should find that x equals 7 over 2, or 7/2. So your x-intercept should be 7/2, comma 0. All right, if you wrote it in decimal form, it's cool too. You can have 4.50. But as long as you got the right answer, that's what we're cool. So now number 2, same thing. It was already in slope-intercept form, so you like that. It gave you the y-intercept right off the bat, so we know it was 0, -3. Make sure you're taking that negative sign with you. All right, and then to find the x-intercept, again, you're going to go plug 0 in for y, work it all the way down until x is by itself. So in this case, you should find that the x-intercept is 3/7, comma 0. And again, decimals are okay to use. Now, on this one, it's not in slope-intercept form. And again, if you want to get it in that form first, cool. That'll give you immediately the y-intercept. But why do that if you're not going to end up graphing? That's a little extra step that you don't have to do. Because we know about this whole trick with plugging in zeros. So I can plug in 0 twice, one time into the x, one time into the y, and I can get both of my answers. So in red, I've shown you how to get the x-intercept, or sorry, the y-intercept. I'm plugging 0 in for x. And in the blue, I've shown you how to get the x-intercept by plugging 0 in for y and doing the work. And those should be your 2 answers that you get once you're done. All right, and same thing with number 4. In red, again, not moving it into slope-intercept form because that's kind of a waste of time here. We're not graphing. So we're going to plug 0 in twice. So the first one in red is plugging in 0 for x in order to find the y-intercept. And here's your answer. And then the second time it's plugging in 0 for y in order to find your x-intercept. And here's your answer. And again, it's a fraction. Who cares? Fractions are not supposed to be hard. So just because you get a fraction, don't think you did something wrong. All right? So if you're comfortable and confident with this, keep practicing. And until next time, keep going.